This is the structure of the adaptive equalizer. This structure is known as a transversal structure. This structure has capital N number of delay elements, n plus 1 number of tap elements, and n plus 1 number of multipliers called weights or filter coefficients. These weights or filter coefficients are adjusted by the adaptive equalizer by means of the algorithm. The input signal Yk and its delayed version are multiplied by their respective filter coefficients, and the sum of products is given as the output of the adaptive equalizer dk cap. This output of the adaptive equalizer is compared with the actual output dk. This difference between dk and dk cap is known as the error signal. This error signal ek will be used to adjust the values of these weights or filter coefficients by means of this adaptive algorithm. Whenever there is an error signal ek, the adaptive algorithm will adjust the values of the filter coefficients. From the block diagram of adaptive equalizer, the input signal to the equalizer in vector form is Yk, and the filter coefficients in vector form is Wk. Then the output of the equalizer dk cap is the product of the sum of the products between the weight vector and the input signal. The same expression is written in vector form Yk transpose into Wk, which is also equivalent to Wk transpose into Yk. Then the error signal, which is the difference between the actual output and the output of the equalizer, dk minus dk cap. Already dk is equivalent to the original input signal xk, so this equation becomes as xk minus dk cap. The expression of dk cap is substituted here. So what is the first one? Yk transpose Wk. So xk minus Yk transpose into Wk. Then it is also equivalent to xk minus Wk transpose into Yk. To find the mean square error, first we take the square of the modulus of the error ek, which is nothing but xk minus Yk transpose Wk modulus square. This is similar to a minus b whole square. So therefore we apply that form a square x, which is xk square plus b square. Since this is the matrix multiplication, this square of Yk transpose Wk is written as Wk transpose into Yk transpose into Wk. Then only the product of these matrices will give the square of this Yk transpose into Wk. Minus 2ab. So a is xk, b is Yk transpose into Wk. Then the mean square error is found by taking the expectation of the previous expression. The expectation of xk square plus Wk transpose into expectation of Yk transpose into Wk. Here the Wk transpose and Wk are not included for inside the expectation since they are constants. Similarly for the third term also, except Wk, here minus 2 into expectation of xk Yk transpose into Wk. Here also the Wk is not included inside the expectation. Inside the expectation. Then from this expression, this the transpose of expectation of xk into Yk transpose is called as the cross correlation vector, and the expectation of Yk transpose is called as the input correlation matrix or auto correlation matrix. So by replacing this expectation of xk Yk transpose by P transpose and the expectation of Yk transpose by R, this is the final expression of the mean square error.